Okay, so that first video, part one, kind of shut off on me, but we'll just continue where we left off. So what I've done here is, in order to find where, if any, this function has horizontal tangents, I've got to find the derivative, because the derivative represents the slope, and slope has to equal 0. So I'm setting that equal to 0. To solve this, when I find my values for x, then I will know the x values where this function has horizontal tangents. So 4x times x squared minus 1 equals 0. And I will set each factor equal to 0 and solve each. So this function, this fourth degree function, does have horizontal tangents. And so those are going to occur at x equals, I didn't do this one, at x equals 0, x equals, and x equals plus or minus 1. Okay, so what does that really tell us? So I'm gonna pull my calculator in here, and I'm gonna let the calculator draw this. So I'm gonna go to y equals, and I put in x raised to the fourth minus 2x squared plus 2, and I'm gonna do a zoom 6 to get it back on a standard window. And looky here. So if you look at this graph, notice that at x equals 1, we have a minimum, at x equals -1, we have a minimum. At x equals 0, we have a maximum. And at x equals 1, we have a minimum. And at each of those maximum and minimum points, the tangent lines will be horizontal. So yes, f has horizontal tangents at x equals 0 and plus or minus 1. And, you know, if I needed a reason, my reason would be because y prime equals 0. Those are the x values where y prime is 0. All right, and we can do the same, or we can write an equation for a tangent line. Y equals, here we have a function, and we want to write the equation for a tangent line to this function at the point 1, 2. So remember, what are the two things we need to write the equation, or to write any equation of a line? That means we need a point, and we need the slope. So to find the slope, that means I have to find y prime. And to find the derivative, or y prime, I have to use the quotient rule. So the denominator's low, numerator's high. So low times the derivative of high, so that's 2x. So low d high minus high times the derivative of low all over low. So that's 2x squared. So I really don't necessarily have to clean this up, because remember, that's where some of us get in trouble. Since I need the slope at a particular point, I'm just going to take my 1 and I will substitute it into the derivative for every x that I have. So that's 2 times 1 times 2 times 1 minus 1 squared plus 3 times 2 all over 2 times 1 squared. So this term gives us 4, and I have to subtract. Now 1 squared is 1, plus 3 is 4. 4 times 2 is 8. So I'm going to have 4, and I'm going to subtract 8 and divide that by 4. We get -4 over 4, which equals -1. So here is the slope of the tangent line through that point. So I have enough to write the equation. So it's y minus 2 equals -1 times x minus 1. And there's your equation for the tangent line. And if you want to take a look at it and you have access to a calculator, you know, you can always graph this. So putting this in, open the numerator. Let me scoot this down a little. I'm opening the numerator, and I will put in x squared plus 3. I will close that. I will divide, and I will open the denominator, put 2x in there, and close it. And I'll do a zoom 6. Actually, no, I'm going to go to y2, and I'm going to put the equation of my tangent line in there. So I'm going to put in my -1 times x minus 1, -1 times x minus 1, and then I will add the 2 over, so plus 2. Now I will graph, and here comes the equation of the function in blue, and in red is the tangent line at the point 1, 2. So there's our point on the graph and on the that's the point of tangency, and the equation for this tangent line that's in red is y minus 2 equals -1 times x minus 1. So it's pretty cool. That's pretty cool. Okay, so on these remaining questions, these are similar to the ones that we did a few minutes ago with the product rule. Here we've said that if f of x equals, now what are g of x and h of x doing to each other? This is a product. So since I have a product of g of x times h of x, the product, I have to use the product rule. And what I've got here is a bunch of stuff about g, its derivative, and h and its derivative. And ultimately what I want to find is f prime of 2. This is what I'm looking for. So first, let's find the derivative. So it's g of x times h prime of x. This is first times the derivative of the second plus the second times the derivative of the first. This is u, this is v. So it's uv prime plus vu prime. Now I'm ready to substitute 2 into the derivative. So f prime of 2 will be g of 2 times h prime of 2 plus h of 2 times g prime of 2. Now just go get all of our numbers, all the numbers that we need. G of 2 is a -1. H prime of 2 is -2. Plus h of 2 is 3. Times g prime of 2 is 1. So what is f prime of 2? We have -2, no we don't, we have +2 plus 3, which equals 5. Okay, and then the last example that we have here is we're going to have this quotient. We have information about g and h, and we want to find f of x, or f prime of 3. So that means find the derivative of the function f using the quotient rule. So it's low times the derivative of high, g prime of x, minus high, g of x, times the derivative of low, h prime of x, all over h of x squared. That's your low. So now substitute 3. So f prime of 3 equals h of 3 times g prime of 3 minus g of 3 times h prime of 3 all over h of 3 squared. Now let's go get our answers or values. What's h of 3? 3. What is g prime of 3? That's 1. Minus, what's g of 3? Negative 4. Use parentheses there. Times h prime of 3, which is 1. And all of that is over h of 3, which is 3, squared. So this is 3 plus 4 over 9, which is 7 over 9. So f prime of 3 equals 7/9. Oops, ran off the page there, sorry. So finding derivatives, you definitely have to know your quotient rule, your product rule. Let me see if I can make this smaller. Not that, that's not what I wanted. I want to zoom out a little bit. So let's see. You've got to know how to find a derivative using the product rule and the quotient rule. We add those to the rules that we learned in the previous lesson with the power rule and the constant rule and so on. You now have a full toolbox of items to use when finding the derivative. So that ends part 2. We'll see you next time.